Now it looks kind of like a long list. It's really just 5 items that I counted. So it's all the same list that I showed you yesterday, plus our online worksheet from yesterday. So thank you to the people who finished that, shared it with me. If anyone's struggling with it or has questions on it, send me a message. We can talk about it through Remind or through email. And then today at 3, I've got my extra time just for your class. So come at 3 o'clock today if you need help on any of these assignments. Just a reminder, my 3 o'clock time, same link. So just use the regular class link at 3 o'clock. Okay, so let's jump into it. Simplify the expression. X to the 4th power times X to the 10th. So I'd like you all to try this on your own. Treat it like this is our test today. Treat today's review as just a practice test. This problem is basically straight off the test from tomorrow. So I tried to order them from I guess kind of easier problems, getting harder as we go. It's not perfect. Sometimes it'll duck back into a little easier if we have a hard one, but I tried to order them. So anyways, this is a good example. So if we had X to the 4th times X to the 10th, can anyone tell me how we can
Would it
simplify
be
this
X?
expression?
Oh, how we can simplify it?
Yeah. Braden,
Well,
what were you saying, sir?
since the base is the same, don't we just add the powers?
You
So
sure
it
do.
becomes X to the 14th.
X to the 14th. Perfect. And I love that explanation. That was awesome. Bases are the same, check. Then add the powers, X to the 14th. Thanks, Braden. Any questions, concerns on a problem like this? Awesome. Okay, let's see. Question 2. Okay, simplify the expression. What do we see? We see 5 to the 2nd power, and that's being raised to the 7th power. So take a minute, see if you can simplify this at least one step, if not more, and let me know what you get.
I kind of I'm a little rusty on this, but obviously we times the 7 by everything in there. But do we add a 1 to the 5 or no? Actually, no, we don't. No, we don't.
Braden,
But we times 7 by 2, which is 14.
there we go. That's
Would
good.
would it make it would it make it 5 to the 14th power?
Absolutely. 5 to the 14th power. Can I ask you, if you don't mind expanding on what you were saying, how come we don't put a 1 exponent for this 5?
Is it because 2 has already took the exponent part?
Beautiful. Exactly. Yeah. This 5 has an exponent of 2. So I loved where you were going with that. And then you stopped and corrected yourself and you saw it. We don't need to put a 1 for that 5, a 1 exponent, because it already has something. It has a 2. Very good. And so we can simplify this to 5 to the 14th. And in the problem you'll see tomorrow on the test, I think this is where we stop. You just answer 5 to the 14th. So stop. This is our answer, our solution. We could figure this out, though. It's going to be pretty huge, I think, astronomical. If you plug this into your calculator, 5 times the 14th power. Yeah, I mean, I don't even know what this is. It's humongous. I'll write it down here just for kicks. It's 6103515 This is, looks like 6 billion. So 14 fives multiplied together. It doesn't seem like it should be that big, right? But it is huge. It's crazy how fast exponentials grow or increase. Like 14 fives multiplied together, boom, 6 billion and change. So anyways, for tomorrow's test, though, we'll stop here. You'll just simplify the expression as 5 to some power, or a number to some power, the base. Okay, any questions? All right, here's a more complex one. There's a lot of different rules at play here at once. We're multiplying this parentheses to the other parentheses. Okay, they're written right next to each other. So 2a to the negative third, all to the fourth power, times 3a to the fifth power. Now remember, coefficients can multiply together. I'll write this down. Coefficients can multiply together. Coefficients are the numbers, the whole numbers that aren't variables. So in this case, our 2 and our 3 are coefficients. Another thing to remember is what Braden was talking about a couple questions ago. If numbers are being raised to outside powers, meaning like outside the parentheses, and they don't have an exponent, make sure to give them a 1. So I'll just cut straight to it. That 2, it looks like just plain old number 2, but notice that it's in the parentheses being raised to the fourth power. So don't forget to give the 2 the fourth power treatment. So I'll say this, everything in parentheses gets outside power. Or outer power, the fourth power. And don't forget about negative exponents. Negative exponents means we change positions, flip that item, that term that has a negative exponent moves up or down, depending on where it's starting. Okay. Now, I'm not going to ask if anyone has like straight up solved this whole thing yet, but can anyone help me with at least one step we could take? What's one first step that might start to whittle this down? Any ideas?
We can times 4 by negative 3.
Good.
And 1 that we put for the
Good.
2, which would make negative 3 to the negative 12. And would we keep? I don't think we keep the 1, right? Or do we?
Let's see. We keep okay. So let me back up with you. You said put the 1 in there, the 1 exponent for the 2. Good. Then you also said we're going to multiply that 4 to our exponents. So
Yeah.
we should have 2 to the fourth power, excuse me, a to the negative 12th power. And Braden, now that you've done that, there's no more outside power for that first parentheses, right? So I'm going to, I guess, kind of just copy down where we're at now. And there's no more like outer powers to multiply to inner powers. So that's good. That's a great first step. I love that. Now we've got 2 different like terms, or I guess expressions, being multiplied together. We've got 2 to the fourth power, and that can like intermingle with the 3 because they're both whole numbers. So pretend for a second, folks, that there's no a's, right? Pretend this was just the 2 to the fourth and the 3. Well, we would multiply those together. They're not the same base, so we're not going to like make it 2 to the fifth or 3 to the fifth, but we can figure out 2 to the fourth. If you multiply 2 to the fourth out, that's 16. And our 3, of course, is just 3. So I've kind of started to combine those numbers. And I guess let's continue with the coefficients, and then we'll back up and check out the a's. So 16 times 3 looks like it's 48. So we dealt with the coefficients. Now let's back up and check out what's going on with the a's. A to the negative 12 times a to the fifth. Now, honestly, this looks just like, I think, the very first question from today. Our rule is if the bases are the same, and they're being multiplied like these are, we can add the exponents. So what do we get when we combine these two parts together? The a to the negative 12 times a to the fifth.
Negative 10. Oh, I'm sorry.
Thank you both for answering. Sorry about the over coverage, but thank you both. A to the negative 7. I heard Braden, and I think maybe that's what the other folks were saying. There we go. So think about problems like this one, question 3. It's multiplication, right? It started off as a multiplication problem. We also had an outside power to deal with. We dealt with that first. Then, once there's no more like outer powers, it's purely a multiplication problem. So mix together, meaning multiply together your coefficients, the 2 to the 4th and the 3. We did that. Then deal with your a's. If there had been b's and c's, then we would kind of go down the list and deal with each one of those one at a time. This is a correct answer, but we don't like to leave our questions or our simplifications with negative exponents. So let's keep going. 48. What happens to that negative 7 exponent? How can I like clean that up a little more and get rid of the negative exponent?
You can convert it to a radical.
Oh, okay. Convert it. Sorry. Let me scratch that and start over. Convert it, yes. Radicals, we'll get into those in a few questions from now. Radicals are when we have the fraction exponents.
Doesn't it like flip? You make into a fraction?
Leisure, yes, absolutely. We flip that term, a to the negative 7. We can turn it into a fraction. It's starting off in the like numerator, so to speak, because there is no fraction. So it goes down. Let me get this thing out of the way. Sorry. It moves down to the denominator, a to the 7th. There we go. So this is 48 over a to the 7th. Now, both of these are mathematically like correct. Both of the ones I circled, but this is our more simplified.
So Josiah, on the test, the more simplified answer would be the answer, right?
Yes,
So if I
yes.
would have put like the step before that, it might be wrong.
Yeah, and if that happens,
Mhm.
then we won't know about it till like after you're done, right? And if you're looking through your results and you see something like this, tell me about it. Say, hey, Josiah, number 3 on the test or whatever. Can you look at that? I think, I think I was correct. I just should have done maybe one more step, and I'll give you half credit, or depending on what the problem is, maybe full credit. So I shouldn't have circled it. So I changed that.
I was just making sure. Sorry.
Yeah, no, it's a good question. And thank you to both Leja and Braden for helping me with that problem.
Thank you for solving it.
Any other questions, concerns on this? Please. Okay, let's keep rolling. And something to my settings. There we go. Question 4. I want to give everyone a chance to deal with this one on your own. And then when you feel comfortable sharing what you got, whether it's the final answer or just 1 or 2 steps in, that's cool too. Just let me know and I want to hear from you. Remember, we've got whole numbers, the coefficients, that's the 30 and the 6. We've got the x's, and we've got the y's. When I look at a problem like this, I think about it in like 3 parts. I want to deal with the coefficients, deal with the first variable x, and then the second variable y. And it's okay to, while you're doing one part at a time, kind of cover up the rest, cover up the x's and y's first and say, okay, if this was just 30 over 6, what does that simplify to? Then do your x's. If this was just x to the 5th over x to the 7th, how can I simplify that? I see some messages in the chat. Let me check that out. All right. I hope it's okay if I address these questions to everybody. So if you need to leave to meet with your normal teacher, I guess that's cool, but then you'll miss our review.
I understand everything.
All right. You ready, Manaya?
Yeah.
Is this your normal teacher time, 10 o'clock?
No, but I'm gonna have to ask him something about school, about some other units, because I understand math. Math is okay.
Well, then I need you to stay on and help me teach this. I'm kidding. About making you help me teach. I guess it's fine. Go ahead and meet with Josh.
Okay, I will be right back.
Okay, thanks, Manaya. And if other folks are having trouble with hearing me, Leja, can you hear me now, or am I still lagging?
Oh no, it was the slideshow. Sorry, it was lagging.
Is it?
Like it was on the other screen for the longest.
No kidding.
Yeah,
Oh, I'm sorry about that.
sorry.
I wonder if other people were experiencing that too. I'm sorry. Can you see question 4 now or no?
Yeah, I see it now. I refreshed my page.
Okay. So if that happens again, try the refresh, and then if not, let me know again.
Okay.
I'll try to be more aware of that. Should we go back afterwards to question 3?
Oh no, you're fine.
Okay. Does anyone have this partially simplified, or maybe a final answer that we could try out?
Yeah, I got 5 to 5x to the negative 2, and then y to the 6.
Very good. 5x to the negative 2, y to the 6th. This is perfect. You did your division, 30 divided by 6, that's 5. You got a negative 2 for the x exponent by doing 5 minus 7. Remember, it's always top minus bottom for the matching variables. So the x is top minus bottom, y's top minus bottom exponents. Now, the only thing we can do one last step is fix that negative 2 exponent. So help me with that. What should we do with that x to the negative 2 to make it a positive 2?
Make it into a fraction.
Make it into a fraction. And then the x goes where?
And wait, no, wait.
At the bottom.
At the bottom. X to the 2. And remember to change that sign, folks. It's when you move it, you're converting it, and it doesn't have to be negative anymore. So it's kind of like paying for the switch, paying for the move. Very good. Thank you both. So there's our answer. Perfect. All right, that was number 4. All right, I'm going to move on to 5. All right, I moved on to 5. I hope everyone can see that. If not, let me know. So we did a couple problems like this, I guess, last week. Here, we are converting, like Braden was mentioning earlier, to the radical form. So we've got the expression below can be written in the form a to the b over c power. And what do we see? We have the radical. We have the 5th root of 3 to the 4th power. There's how we say that. 5th root of 3 to the 4th power. Okay, so this is simply a matter of identifying how do we convert it? How do I turn this radical form into the power form above, the a to the b over c power? Anyone want to take a stab at this with me?
Is it the 3 is the A,
Good.
and then it's the 4? Is the outside the denominator?
The outside is the
Or-
denominator. Perfect. Yeah.
Yeah, okay. Yeah, 4/5.
Jayla, thank you. High five. Yep. B is our 4 and C is our 5. Perfect. Yeah. I like what you said. The outside is the denominator. So whatever the root is, that's the outside. And that's our root. I'm going to call that both root and outside. Our 5 in this case, that's the denominator. Is the denominator. Cool. And then if there's another inside power, like here we have the 4, that's our B. If there's no number inside there, like if this was, side example, if this was only 5th root of 3 instead of 3 to the 4, then when we convert it, we need to put a 1 for that B position, because it's just like when we do our like power to a power rule earlier, we need to remember to put that 1 in there for that exponent. Otherwise, it's going to be missing something. So this would be 3 to the 1/5. Just for a side example, if there's no extra power to whatever base is inside the radical. Awesome. Any other questions, concerns on this kind of problem? Okay. Number 6. Okay, this is like work from last week. Simplify the expression 80 times 81 all to the 1/5 power. The 1/5 power. Now, a couple notes I'll throw in here on the side. Our answer, solution, is going to be in radical form. So that's our main goal here, is to turn this into radical form. However, we also want to simplify as much as we can, and that means get like the 80 and the 81 to break down, and then look for groups of 5 items, because this is a 5th root here. So this tells us we need groups of 5 items to simplify. Meaning like 2 to the 5th power or 3 to the 5th power or something like that. So how to start a problem like this? Whatever is being raised to the fraction exponent. Normally it's just one number, but this time it's 80 times 81. So start by doing the factor tree for whatever's the base. In this case, 80 and 81. Start by making factor tree. So I'll start that off to the side here, 80. You can always just divide by 2 and 3, like the lowest prime numbers, divide by 5. Or if you see a bigger number, go ahead and start with that. For this one, I'm going to start with 8 and 10. 8 times 10 is 80, and then break down those further. Remember, you keep going with the factor tree, like keep dividing it by numbers until it's only numbers that are divisible by themselves in 1, prime numbers. And if you're unsure about that, like what are prime numbers, just try it. For instance, 5 here, like if I'm not sure, is that a prime number? Try dividing it by 2 and 3 and 4. And if you're not getting whole numbers, all the way up until you get to 5, it's prime. Okay, so 80 is... Oh, you know what? I think I made a mistake here. I remember this problem from this morning when I made this. Oh, rats, I'm sorry. Okay, everyone. I do want to... I hope this isn't too disruptive. I do want to change this problem, question 6. I meant for it to be the 4th root, not the 5th root. So I'm sorry about that. I'm going to rewrite it here. 80 times 81 to the 1/4 root, okay? So group of 4, let me cross this out, and let me cross out the original. I'm sorry about that. So our problem for number 6 is 80 times 81 to the 1/4 power. Okay, our factor tree is still good. So this is 2 times 2 times 2 times 2 times 5. That is 2 to the 4th times 5. And now we'll do it for 81. 9 times 9. And that is 3 to the 4th. So we did the hard work already, which is just breaking down 80 and 81. And now I'm going to substitute those back into the original problem. I'm going to box this off to kind of keep it all separated. And here's my work now. So back to the original, my 80 times 81 becomes 2 to the 4th times 5 times 3 to the 4th. That's the 80, and then the 3 to the 4th is the 81. And that's all inside this 1/4. Okay, now we're not dealing with radicals. I would suggest not converting it to a radical yet. Why are we waiting? Because I want to cancel out these powers as much as I can. That'll help me see what goes in the radical. So we've converted. We've got groups of 4. So if we multiply our 1/4 power to all those inside powers, we'll get some canceling. 5 doesn't have an exponent. Give it a 1. Now multiply the powers. So we've got 2 to the 4 over 4, 5 to the 1 over 4, and 3 to the 4 over 4. So my 2 and my 3, that just becomes 2 and 3 because the exponent turns into a 1. Okay, I'm going to move them next to each other just for the sake of like organizing. And then my 5 to the 1/4, that is stuck. There's nothing really else we can do with that. Can't deal with can't simplify that exponent any further. Okay, 2 times 3, there's no exponents there. So treat those like coefficients. Treat those like just regular old numbers. That becomes 6. 5 to the 1/4, now it's time to convert this thing. So 4th root of 5. So my answer is 6 times the 4th root of 5. In Edmentum, our answers will be converted to radicals. Okay, any questions on this problem, please? Concerns? All right, I'll wait a few moments in case people are still writing down, and then we'll look at question 7. All right, I see something in the chat. Oh yeah, to that message in the chat, that's okay. Just go ahead and come back when you're ready. All right, let's do number 7. All right, this one is scary looking. So I just copied it straight out of the test. Maybe I made it too big though. I wanted to make sure everyone could see it. Okay, so question 7. Select the simplification that accurately explains the following statement. So what we're dealing with is right here at the top, we've got the fourth root of 2 equals 2 to the 1/4. That's like the conversion, right, from radical to power form. And what they're asking us to do is kind of show us properly using the rules which one of these options below, A, B, C, or D, is accurately using the rules. Is like proving that the radical form equals the root form or the power form. So let's start with A and we'll just kind of check it out, see if it makes sense. And if it does, it's our winner. If it's not, it's something else. We'll move on. So we start with 2 to the 1/4 power to the 4th power. Okay. And notice if you look down the list here, they're all starting like that. It's all 2 to the 1/4 to the 4th. We haven't done proofs together yet. And frankly, this whole semester isn't really about proofs. But what we're seeing here, folks, is a math proof. Notice that on the left, right here, these are all 2 to the 1/4 to the 4th, all the way down for the options. And we know from our rules, like outside power multiplies to inside. So that would be 4/4 power. And that reduces to 1. So really what we're looking at here is 2. And at the far right, over here, here, and here, these are all equals to straight up 2. So what we're kind of comparing is the differences in the middle of each line. Basically, I think only one of these is going to be accurate, and the rest will have like some weird mistake in logic that's not using the rules properly. So back to A. So we're looking at 2 to the 1/4 to the 4th. Okay, so then we have this section. 2 to the 1/4 times itself 4 times. So what they did was expand out that 4th power. It's 4 parentheses in a row, right? And they dropped the parentheses. It's 2 to the 1/4 times itself 4 times. That's legitimate. That's expanding the 4th power. In the next step, they've added all the exponents, and it's just one base now. Why? Because it's the same base. They're all 2's. That's good. So we can combine them and add the powers together. And when you do that, you get 1/4 plus 1/4 4 times. That's 4/4, which of course is 2 to the 1, which of course is 2. So option A is accurate. And spoiler, that is the answer here. Now, real quick, let's just look at option B and see what like the weird mistake is. So that way, if these are jumbled up tomorrow and you get it in a different order for your answers, you'll hopefully be able to look through and deduce which one is like accurate and which 3 are bunk. So let's look at B. Starts off the same, and then they expand it the same way right here. So this is true so far. And then they say this is equal to 4 times 2 to the 1/4. That is true. Yeah, that is true. Repeated addition is multiplication. So if you have an item being multiplied to itself like X amount of times, then that should be true. So it looks like right here is where a mistake is made. Then they go from 4 times 2 to the 1/4, all of a sudden equals 4 times 1/4 times 2. This is not true right here. So they were good, and then they were good, and then they just made up some weird stuff with that exponent being multiplied to everything all of a sudden. Not true. So basically, this is like inaccurate because of that step right there. I don't think I'm going to go through all the rest. And just so you know, this problem is, exactly the same. So in a way, I'm kind of just giving you this one for tomorrow. Any questions or concerns on this problem, please? I hope you didn't, sorry, I should have said this earlier. I hope you didn't copy this whole thing down. This is the kind of thing where it's okay, in my opinion, to just take a picture if you want to, because it's like so much writing, and we're just doing a multiple choice answer. So no questions. I'm going to move on. Let's look at question 8. All right, simplify the expression. Okay. Now, this one might look kind of scary at first, but frankly, if we use our rules, it should simplify pretty fast and nicely. So let's just kind of survey before you start doing stuff. We've got fraction exponents. So right off the bat, I know I could convert these. I could convert these to radical form. However, I'm hoping that we get some like canceling and simplifying, and maybe that 13/4 and 7/4 whittle down to smaller numbers, right? So in the spirit of hoping that I can do some simplifying of those fraction exponents, it might be best to hold off on radical form until later, till we're all done. So I can deal with this divided. I know what that means, right? It's the first item divided by the second item. So let's rewrite it that way to start. Maybe it'll become a little clearer what we're looking at. So the whole first item, exponents and all, divided by the second item, 3 to the negative 7/4. Look, they're both out of fourths, 13/4, 7/4. So that's good for us. That means that we can add and subtract those fractions pretty easily. We've already done some problems earlier with similar to this, where we have same base, 3 and 3, and one's on the top and one's on the bottom of a fraction. And we know that means top exponent minus bottom exponent. So 3 to the top exponent minus the bottom exponent. Now, this is a little tricky. It's minus the bottom. The bottom is already negative. So I'm going to make sure I keep track of that here with the parentheses. So I've got the top minus the bottom, and the bottom is negative, so it's got the double negative going on. So it's just a matter of adding those fractions. Remember, minus a negative turns into a positive. So it's just the top numbers, because this is read 13/4 plus 7/4 for a total of 20/4. Now, we could convert it now, but it's a little easier to work with it in fraction form or power form if it's reducible, right? 20/4 is reducible. 20 divided by 4 is 5. And look at that. We've eliminated the fraction altogether, so no need to do the radical. We could have done that from the beginning. However, then we're doing factor trees. We'd be either multiplying or dividing our two terms together. I think this was cleaner to keep it in power form first. So we've got 3 to the 5th power, or otherwise known as 243. And real quick, I want to show you an alternate way we could have done this. So from the top, 3 to the 13th over 4 divided by 3 to the negative 7/4. So another way we could have approached this is, instead of doing the top minus bottom rule, which is valid, you could have said, oh, okay, I've got this negative exponent. I want to convert that. I want to convert the 3 to the negative 7/4 and move it up. I kind of like this way better. Actually, I don't know why I did it the other way. but they're both valid. So I move it up and it becomes 3 to the positive 7/4. Now I've got same base, same base. They're being multiplied. So that means I add my exponents, which means I can write this or do this in my head, right? 13/4 plus 7/4. Okay, cool. So 20/4. The reason I like this approach better is because I didn't have the all those negatives to make it more confusing. So it won't always be obvious, like which way's the cleaner way. But I hope that you see that no matter which way you choose, if you follow the rules, all these different power rules we've been learning and using, we do get the same answer. Like these different things are equal to each other. We still got 3 to the 24th, which is 3 to the 5th. It's the same thing. And that goes for even if we had turned it all into radicals. It would have been, I think, messier, but it would have worked. And we could have still solved it if we had like converted it to radicals from the beginning. Any questions or comments on this problem 8? Anyone need more time with this? Okay. Let's look at number 9. Number 9, simplify the expression. We've got 8 root 3 times negative 2 root 5. So a note, remember, coefficients, the outside numbers, the non-root numbers, they can interact and multiply together. And then also the matching roots can multiply together. Coefficients. I don't think we're going to have any really crazy trick problems with like non-matching roots. I've double checked the test a couple times. I didn't see that. So, but I want to be clear with you. It's only matching roots that can multiply together. That means like 2 square roots could multiply together, or 2 third roots or 4th roots could multiply together. 2 12th roots could multiply together. Now in this case, we've got square root of 3 and square root of 5. So what I want you to do, multiply the 2 outside numbers, the coefficients. Multiply the 2 inside numbers. And what do we get? Take a stab at this and let me know if you have something you'd like to share, any idea on simplifying or an answer if you've solved the whole thing. All right, did anyone get 1 or 2 steps done of simplifying here that I'd like to share? Be willing to share?
The 8 times -2 is -16.
Very good. Yep, we can do that for sure. They're both outside numbers. They're both coefficients. And we've still got the √3 times √5. They're small numbers. If we try to factor tree those, we should see they can't be, right? 3 is a prime and 5 is a prime. So think about it this way. I can multiply together my matching root numbers. So basically it's square root of 3 times 5. It's just some side work here. So √3 times √5. If I just focus in on my root numbers and multiply them, it looks like that. If I jam them together into 1, 3 times 5 together, and then √15. So we've got -16 √15. This can't be simplified further. If I try to break down my 15 with a factor tree, that's just 3 times 5. And these guys are both prime, 3 times 1, 5 times 1. So we're done. We would need a match of 2 items inside there to simplify that √15. Any questions? Concerns? Okay. All right. We did some like this last week. This is number 10. Which expression is equivalent to 10 √5? And then they give you these options below. What they're asking you to do here is basically the opposite of what we normally do. Think of the options below as kind of like how our problems usually start. It says simplify. Well, the answer to that is 10 √5. So how do we work backwards and figure out what that is equal to? One way is just to kind of plug them all in your calculator and see which one is equal to whatever 10 times √5 is. Here's another way we can do it. 10 √5. Now, if I convert this to power form, this is 10 times 5 to the 1/2. 10 is not being raised to the 1/2 power, but I am allowed to say it's 10 to the 2 over 2. So that's kind of a trick move right there. Is saying, okay, 10 is the same thing as 10 to the 2 over 2. But that's true, right? Because 2 over 2 is 1, 10 to the 1 is 10. So we're just using our exponent rules in a tricksy kind of way. Okay, now that they both are fraction exponents with a 2 denominator, we can do this. We can do the backwards version of the power to a power rule, which is I'm pulling out a 1/2 power from both of those terms. Normally, we start here and then multiply the 1/2 in. But what we're doing now is the opposite. We're undoing that action and pulling it out. And now in my parentheses, I can figure out what these are. 10 to the second power is 100 times 5. So that's 500 to the 1/2. And if I convert that back to radical form, that's square root of 500. So this is kind of tricky, I grant you. And we have to I guess right here is an important step. And then this is a tricky step here where we did backwards power to a power rule. All right, we've only got a few minutes left. I want to do one or two more if we can. So let's move on. Number 11. Okay, take a minute and try to break this one down. This is a good one to start with. Simplifying square root of 28. So start with a factor tree. And then this is a square root, so we're looking for groups of 2 items or things to the second power to simplify. Let me know if you are able to break it down with the factor tree and tell me what you get. And then we'll continue from there.
Could it be 2 to the second power and then 7?
Good.
7?
Awesome. Thanks, Leja. So she did this. 28, maybe you cut it in half. Got 2 times 14. Cut that in half. 2 times 7. And she got this, 2 to the second times 7. Very good. So if we replace that into our radical, we're looking at this, 2 to the second times 7. Now, I'm going to use the power form. So I'm going to convert this business into power form. So it's the whole base, 2 to the second times 7 to the half. And now it's a little easier to see our next steps. 7 should have a 1 exponent. Multiply that 1/2 to the parts inside. Powers. So 2 to the 2 over 2. Sorry about all the 2's. And then times 7 to the 1/2. Now at this stage, can anyone help me finish this up?
Two to the 7 1/2. Or like it'd be
Oh, yeah.
2.
Yeah, no, you're right. 2 times 7 to the 1/2. Great. And now can we convert that 1/2 back to radical form?
No?
Sorry. We can. Remember, the 1/2 power
Mhm.
just means the square root of whatever the base is. So just like we did back here, well, right here in these 2 steps, this conversion I did, we can kind of go backwards and do that conversion the other direction. So 2 doesn't get a radical because there's no fraction exponent, right? So it's just plain old 2. 7 to the 1/2 becomes square root of 7. So like I've been saying, where we left off right here, the second to last step, this is legitimate. It's a legitimate answer. It's mathematically true and everything. But Edmentum and most math teachers, honestly, are going to expect something like this, 2 root 7. So here's our answer. Leja, thank you so much for helping me. That was awesome.
Thank you for correcting me. Jeez.
Well, I'm sorry. I didn't mean to.
Oh no.
Make
I really thought it was like 2 to the 7th 1/2. Like I thought that would be the final answer. I'm glad you corrected me.
Well, thank you. I didn't mean to be rude. So I'm working on that. Apologies. 7. Yeah, I just was excited that you were helping and you were on the right track. But it's just that we can convert it, and generally they're going to want to see that radical form. All right, it's almost 11, so I'm going to stop here. I did have 2 more problems, but we've covered most of what's on that test tomorrow. So tomorrow the plan is to take our test as a group. I think it's a 20-question test. I'm hoping that we can get it all done in one like class. I think we will. So my plan is to have you all take it individually, and but stay with me on the call, and then we can, if you need clarification on anything, you can ask me. We can talk about it, and try to help. So I've got roll taken already. You all have a wonderful day, and thank you so much for your participation and for your hard work.
Thank you.
Bye, Leja. Thank you.